We continue with solving equations of the form ax squared plus bx plus c equals 0. So far we have solved them using factoring. And there's an example, and we know the majority of real-world problems don't factor. We've solved them using the square root property. Now, I run into this frequently with applications, so this guy you'll run into. And then yesterday, we completed the square. And so that's an example of completing the square and how that's worked. But we add a new method, and the new method is a formula called the quadratic formula. Just have to remember it. Some people have remembered it, and there are teachers who've taught this, and maybe those of you who have had this before had a teacher that did the quadratic formula to Pop Goes the Weasel, the old children's song. You haven't? Look it up on online and just no, because I don't remember it that way. But that is a way of remembering it. Just type in quadratic formula, Pop Goes the Weasel, and there's a YouTube video with a guy singing it, and it might find it helpful to remember the quadratic formula that way. I used it this morning, by the way, in college algebra, so 90% of the quadratic equations you will end up having to solve, you're going to have to use a quadratic formula for. So, and what the quadratic formula says, if I have an equation of the form ax squared plus bx plus c equals 0, that x is minus b, that's the coefficient of x, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's a quadratic formula. Now, you might ask the question of where does it come from? Now, your book actually went through this for you as well. And it comes from completing the square. And it makes sense that somebody who would go to the whole thing of trying to, and you had to solve quadratic equations over and over and over again, and you would start doing it by completing the square on it, is you'd ask yourself, then can this be done in general? And then you look for taking ax squared plus bx plus c and complete the square on it, and then that's how the formula was gotten. Remember, the first step was make sure the coefficient of x squared is 1, if not divide it out. It isn't. It's a, so you divide everybody by a. Then x is on the left, numbers on the right. Then you complete the square on the x's by taking 1/2 times the coefficient of x, the quantity squared. So that's 1/2 times b over a squared, which ends up being b squared over 4a squared. And then you add that thing to both sides. Left-hand side is now a perfect square, trinomial square. And then the right-hand side, you're going to have to end up putting over a common denominator. So that's what you see beginning to happen here all the way down the line, is that you finally put that right-hand side over a common denominator, which happens before a squared. Then you rewrite this as the perfect trinomial square that it is. And then here, this is now over a 4a squared. Then what do? You take the square root of both sides. Don't forget the plus or minus. And simplify the radical. So the numerator ends up being the square root of b squared minus 4ac over the square root of 4a squared, which is just 2a. And of course you end up with x plus b over 2a. So simplify the radical, solve for x minus b over 2a, and then 2a common denominator, and then there it is in all its glory, the quadratic formula. It's gotten by completing the square.